All right, this is our 5th lesson for Introduction to Polynomials for Chapter 5. Hopefully you have finished 1 through 4 and you've done your keywords quiz, so everything that we're talking about here should not be new to you. Okay, so just to start, I want you to write an expression to represent the length and width of the following rectangles. So we're only looking at the side lengths. Don't care what type of tiles are in the middle. We're just looking at the side lengths for now. So if this was a rectangle, which kind of it is, we have a length of x and then a length of 1, and then we have a length of x and a length of x, or I guess width. So if we said the full, I'm going to use different colors. If we said the full length is x and 1, this is x plus 1. And when we're talking about the width, that's 2 x's, so we have 2x. Okay, so that means x plus 1 times 2x gives us 2x squareds, right? X squared, and then 2x tiles plus 2x tiles. So just a little review. Slide these over a bit. Okay, we'll do the same on the second one, looking at length and width. Okay, so we have a length of x and x, so there's a length of 2x. And then the width is x and x, so x and 1 and 1, so 2x plus 2. So 2x times 2x plus 2 gives us 1, 2, 3, 4x squared plus 4x's. So just thinking of like rectangle, areas length times width, that kind of thing. So that was kind of like what we did a little bit in lesson 4. We're going to keep building on that idea. Okay, so the next thing I want you to do is we want to start putting expressions into like terms. And so when we say like terms, we want to put them with things that go together. So let's start by saying what like terms are. So like terms are terms. So they could be letters, they could be numbers, but there's no addition or subtraction signs connecting two terms. They're only single terms, so monomials. Okay, so they are terms that have the same variable, so the same letter, with the same coefficient. So if we're thinking in terms of algebra tiles, so in algebra tiles, they are the same shape. So if you remember back to the demo we did for lesson 3, when we started looking at algebra tiles, we said that you can't just take a handful of algebra tiles and say, you know, I have 10 algebra tiles, I have 10 monies. It's just like when you're a little kid taking all your change and adding them all together, even if they're not the same value, but counting them all the same. So you really have to be careful when you're looking at like terms that we are actually adding the same variable to the same coefficient. So it's not enough that they're both x's, they both have to be x to the power of 1 or x squared. So that way they represent the same shape. So that being said, if I said negative 8x, something that would be a like term would be 2x, because they both have an x to the power of 1. And that's the only one. If I said 4y, well, 4y and 3y go together because they both have y to the power of 1. 7x squared is we have the variable x to the power of 2, so it's the shape of a square, and then negative 6x squared goes together because it's the same variable to the same exponent. So if you notice, we're not really paying any attention to the coefficient. The coefficient in front doesn't really matter. That's not important when we're doing like terms. And then lastly, we have 12xy and 5xy. And so basically those were those rectangular tiles we looked at that had a length of x and a length of y. Okay, so then over here we have 3yx. So basically what they've done is they've taken that tile and they just turned it the other way. So it's still the same shaped tile, but it's just been turned. So this is also a like term. We should get in the habit of always writing our variables in alphabetical order. So that way it's a lot easier to identify like terms. So if this one had been written in alphabetical order, then it would be a lot easier to see that it is the same as 12xy and 5xy. Okay, so we are going to simplify by collecting like terms. So when you're simplifying, you should be making it easier, meaning there should be less terms when you're done. So when we look at this first example, we have 1, 2, 3, 4 terms. So we should have less than 4 terms. So I always start by separating the terms with the dashes so that I can see what I'm dealing with. And color coding is helpful. So I have x squareds. So I also want to work my way down. I want to find the highest exponent that I can and work my way down until I'm dealing with constants with no exponents. So the x squared is the highest. So I'm just going to rewrite it in order. So negative 3x squared and negative x squared. So these are my 2 terms that I'm going to need to combine, and I'm going to need to remember my integer addition and subtraction. And then I have a 5x. So if there's no sign written there, remember it's positive. So positive 5x, and then positive 2x. And so these terms are the same, so they're going to be combined. This line that I've written out, you won't always do this line, but for now it might be helpful to see it. So negative 3x squared and then another negative x squared. So this makes negative 4x squared. That's like you owe me $3 and then you owe me another $1, right? There's like a 1 there. And then positive 5x and positive 2x is going to make positive 7x. You might find it helpful to build with algebra tiles. So if you built this polynomial and then grouped the shapes that look together. We're going to do this in class tomorrow. It's really hard for me to demo this in a video for you using the smartboard. So we will definitely do that tomorrow. We'll do B the same way. So again, we're going to start by separating into terms. Oh, sorry, let me go back to A for a sec. And so now we have a binomial, and they both have the same variable x. But one is x squared and one is x to the power of 1, so they don't represent the same shape. If you remember, x squareds look like this. Okay, so this is 4 negative x squareds, and then we have 7 positive x's. So the positive x's are going to be colored all the way in, and they're going to be like this shape. So 1, 2, 3, 4, 5, 6, 7. So once you see them as the shape, hopefully you can see that, okay, we can't put those together. They're not the same shape. We can't have those. So now let's go to B. So again, I'm going to look for my highest, separate my terms, and then look for my highest exponent and work from there. So just the x, those are the highest. So 2x, and it's a positive because there's no sign, so it's positive 2x, and then negative 2x. And then negative 6, and positive 1. So I'm going to combine my like terms. So the x's I combine, so I have 2 positive x's and 2 negative x's. Well, hopefully you can see that these equal to 2 0 pairs. So they cancel each other out. So that's equals 0. And then we're going to combine negative 6 plus 1, and negative 6 plus 1 is negative 5. So all of this for B simplified down to just a negative 5. Okay, and again, we could use our algebra tiles to help show that a little bit better. Okay, so I'm going to show you how to do this with algebra tiles. So I would like you to take a second and either sketch it or build it if you're doing this at school and you have algebra tiles. Otherwise, sketch it out, and then we're going to use the cross-out method. So by the magic of the computer and the internet, I was able to build that really quickly. So we have 4x, negative 2x, positive 3, and then negative 6. So then the next thing we need to do is we need to group the tiles together to make 0 pairs. So remember, one positive x and one negative x will cancel out to a 0 pair. One positive 1 and one negative 1 will cancel out. So when we're grouping them to make 0 pairs, 2 positives and 2 negative x's will make a 0 pair, and 3 positive 1s and 3 negative 1s will make a 0 pair. So then we only have a few x's left and a few 1s left, so we can write our expression. So we have 2 positive x's right there, and then 3 negative 1s, so 2x minus 3 is what's left when we combine our like terms. So for b, I would like you to do the same thing. So take a second, pause the video, sketch it out. Remember the difference between x squareds and x's. If we separate it into the terms, 1, 2, 3, 4, 5, 6 terms, so you should have 6 different little groupings that you build, and then we're going to organize them. Okay, so you should have built something like, or sketched something like that. So we have 2x squared plus 3x minus 1 plus x squared minus 4x minus 2. So then the second thing we do is we need to group the tiles to make 0 pairs. So we're going to put all the x squareds together, all the x's together, and all the 1s together. So when we do that, it looks something like this. Okay, so now we have 3x squared, and there are no negative x squares to cancel out. We do have positive and negative x's, so then these are going to cancel. So those make 0. So we're left with negative 1x, and then negative 3. And then the third step, we're just going to write the expression of the remaining tiles. So this is what's left. So we have 3x squared, negative x, or negative 1x, and negative 3. Okay, either way you write it is fine with me. And we do always want to write it in terms of biggest shape to smallest shape, or highest exponent to lowest exponent. Okay, and so that is it for lesson 5.